Hello, pre-calculus, Mr. Quirk, and I thought I'd make a little video today to talk about the second learning target of the week for Chapter P. Monday and Tuesday we had fourth period and fifth period. Whoop whoop! Right? If you're here from fourth period, let me hear ya. Woo! If you're here from fifth period, let me hear ya. Woo! All right. um, and we looked at the notes in class, and I posted the notes on Google Classroom for you to kind of read over on your own about the different subsets of the real numbers, right? So you have real numbers, and inside the real numbers, we had rational and irrational, right? Rational numbers that can be written as a fraction. That would be any decimal that stops or repeats itself can be written as a fraction. That's a rational number. The irrational set were the numbers that can't do that, right? Like pi and like the square root of 7. There's even another funky number called E, the number E, real talk, which we'll get to this year in pre-calculus. I hope talk about the number E because I don't know that you did that in algebra 2, but that's an irrational number. It's like pi. It's a decimal. It keeps going and going and going. Inside the set of rationals, remember we had integers, which were whole numbers and their opposites, which means inside the set of integers we have whole numbers, which are 0, 1, 2, 3. And then inside that set we had the natural numbers, right? And each of those numbers, each of those sets have their own little symbol and whatnot. And a lot of you guys submitted your work from that assignment Monday and Tuesday, so that's good. If you haven't finished that yet, get that done. But you see, our second learning target of this week is to talk about intersection and union of sets. Okay, I'm gonna make myself go away here for a second because you know you don't want to look at me. Ew. As we go through these notes on intersection and union, and obviously you know what intersection means. Maybe you know what union means of sets, but to formally write it out mathematically and to show you the symbols today is kind of the purpose of this video, to see the notation. These are notes that are, typed up from your book, and so just notice this is separating commas. The first thing they talk about before intersection and union is what is a set, right? And obviously, you probably have your own conception in your mind of, well, set's just like, a group of stuff, right? A collection of objects whose contents can be clearly determined. Right? Each of those objects in a set is called an element. So if you talk about the set of numbers for counting, right? Or the natural numbers, the set of natural numbers. That would be the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But how do you write that? You've seen this before, most likely, but maybe forgot or never really understood exactly what it meant. But we use these squiggly little parentheses to indicate a set. Okay, those squiggly little parentheses are called braces. So the set of natural numbers, right? And remember we had the natural numbers was this capital N, but it's actually got like a double line on the diagonal, sort of like that. That's the most terrible natural number symbol ever written, Mr. Quirk. Try neater. There we go. That's better. That would be the set of natural numbers right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up forever, right? That's an N. I'm still not happy with it. So inside the braces, we can list the elements using a comma. The dot, 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 dot would indicate that it keeps going forever and ever and ever, okay? So this is literally the set of numbers. 1, 2, 3, 4, 5, 6, 7, 8, on to forever. That's the set of natural numbers. Squiggly parentheses are braces. Another way you can list a set is to even use a description, or using inequalities. Notice here from the book they use a description, but I might write it again in a second. But notice it's the squiggly parentheses, right? Indicate the set of. Okay, so this is literally read the set of, and then the variable x, the set of x with this vertical line is such that. So I'm talking about this group. And what is this group? This group is the set of X, such that X does what? X is a counting number less than 6. Okay? So another mathematical way to say that is to say that such that X is in the natural numbers. Okay? X is an element of the natural numbers. Less than 6. So I could say less than 6. Quote. Right? That's how I'm really writing all this out. Less than 6. Try to denote each of those little bits at a time. The set of X such that X is in the natural numbers less than 6. Okay? The previous set, the first one that was written over here on the left side, we could say that, using the same notation, X is the set of X such that X is a natural number. oh, oh my goodness. X is in the natural numbers. That's my braces. So that way you don't have to write the numbers with the commas and hit the dot, dot, dot. So there's just multiple ways to do this, okay? And am I going to look for you all to necessarily have to write everything like this? Like I have to write out with these braces and the vertical line thing? That's weird. What's most important, honestly, is you being able to read it and understand it. Because if you have a question, multiple choice question, and it's which one of these is it? You have to understand what this notation means. And honestly, in Algebra 2, this notation is used in a lot of Algebra 2 books. So I'm hoping that maybe you're familiar with the little braces. You've seen them before. But they mention it here, the first section of the pre-cal book, using this set notation, okay? And that vertical line is such that, okay? It's kind of a weird thing, but there are lots of symbols in math. As a matter of fact, there's a symbol for the is in right back here. I'm changing this. X is an element of, or is in the set of. This little like funky E, it's almost like a C, a lowercase c with a line through it. It kind of looks like a capital E. But that means that X is in the set of, or X is an element of. So, like over here, I can get rid of the is in and write the set of X such that X is an element of the natural numbers less than 6. So another way to write that, boop, boop, X such that X is an element of the natural numbers less than 6. And see, that's a more mathy way to write it rather than having to use words at all. See all these words up here? Is a counting number less than 6? We can do it without all those words. See, that's the fastest way to write it here. So this happens a lot with like set notation, is using these symbols. So this is literally, I think of this as is in, or is an element of, the natural numbers less than 6. Is an element of. Some of you guys may go on and take lots of math in college, right? Who knows? Who knows what you're going to do? Some of you guys might go on to work for your uncle's construction company, and then take it over and make more money than I do. So it's not all about college, I'm just saying. But if you take upper levels of math in college, these symbols get used a lot. There are lots of symbols in math that you probably don't know yet. Anyway, so the main part of our learning target here was that I can, right, remember, scroll back to this, I can find the intersection and union of sets. So I have 2 more slides, right? One's on intersection, one's on union. And then these notes will be finished, and hopefully this will be one of the shortest videos I've ever made. We'll see. The intersection of 2 sets, intersection, I'm going to denote intersection here and point out it has an N in it, right? The intersection of 2 sets, A and B, written as A with this funky like upside down capital U. And if you think about an upside down capital U, it kind of looks like the letter N, like a lowercase n. I mean, it doesn't have this like little taily part coming back on it, but the intersection of A and B uses the word and. And if you think about the word and, right? If you look down at this tip, that and has a letter N in it, right? So I'm sure you all have the concept of what intersection means. Um, you could be a senior that's in the band, and you could be a freshman that's in the band. And seniors and freshmen don't have a lot in common, right? Because freshmen, ew, stinky. Seniors, super cool. But you could both be in the band, right? And maybe in the band you give the freshmen a little bit of slack because they're helping you out playing music. So that's like an intersection of the two sets, right? Usually freshmen and seniors are like separate. They're disjoint sets. They don't have anything in common, right? So the intersection is a question of what do they have in common, okay? You see the formal definition here is that A intersect B, okay? That's how that's read. A intersect B is the set of X such that X is an element of A and X is an element of B. So it's the set of X such that X is in both A and B. So, and you see the Venn diagram on the right side there. You have, again, the freshmen. How about I put ninth? And you have the seniors. Normally, those two groups don't, interact too much. Maybe you're a senior, you have like a freshman brother or a younger freshman sister, right? But it's possible that there's a ninth grade band member and a 12th grade band member, so they're both in band. Or maybe you're both on the soccer team, right? Not too many freshmen that usually play varsity, but still, it's what you have in common. So find the intersection of 7, 8, 9, 10, 11, and 6, 8, 10, 12. So basically, what do they both have in common? The first set, notice set A has a 7. Does set B have a 7? No. So it's not in the intersection. And at this point, you guys are probably like, Quirk, we already have the answers to these two examples. Like, you can move on and make this faster. Look, there's an 8. They both have 8 in common. Look, set A has a 9, but set B doesn't. Set A has a 10, and look, they both have 10 in common. Set A has an 11, right? But set B doesn't. So, and then the 6 and the 12, they don't match with set A. Set B contains those. So, boop, boop, beep, beep. I'm going to undo all that just because now it's like, I can't see what you wrote. You wrote over top of everything, right? 8 and 10, both sets have in common. So, what is the intersection? The intersection is the set, right, with 8 and 10. Now, if you write the answer without the little squiggly parentheses, right, without the braces, that's okay. I'm not going to count it wrong. That is the intersection. But if it's like a multiple choice question, or maybe you're checking the answers, in the back of the book, because you know how every good math book has odd answers in the back, and you see those little squiggly braces, I don't want you to freak out and be like, "What do those mean? I don't know what that means." So that's why we've gone over it. If a set has no elements in it, that set is called the empty set, also called the null set. Null, null set. And it's represented by this symbol, like a circle with a slash through it, okay, meaning it's not there. There's nothing there. So if you think about the set 2, 4, 6 and the set 3, 5, 7, or even the set of all even numbers is set A, and the set of all all odd numbers is set B. Even and odd numbers have nothing in common, right? There is no intersection. The intersection, right? Again, intersection. So this symbol means intersection of 2, 4, 6 and 3, 5, 7. That is the null set. Okay. Now, when I was in high school, my high school teacher did this. He did this a lot. This was like his thing. When there was no solution, man, I'm struggling with this other brace. There we go. When there was no solution, right? There is no answer. He would do the set notation with the parentheses and the squiggles, right? The braces, but leave it empty. Notice there's no answer in there. It isn't literally an empty set. It's a set with nothing in it. So you can do either one of those symbols as well, but I think our book focuses on this one. Okay. So on the back of the book, they may have that symbol as the answer. Not that any of you are going to have a book because you don't have a book, but the intersection of even and odds doesn't have an answer. Again, you would not want to say that the answer is 0. Okay, like the number 0 does not indicate there isn't an answer. The number 0 indicates that 0 is the answer, and you don't want that, right? So you don't want 0. So we have like the 0 with a slash through it. That means there is no answer. So then the last thing is the union of sets A and B is written with a big U. Okay, cool. So think about the word union. Union starts with a U, right? The union of A and B is everything in set A and everything in set B all put together in one. So like you notice the Venn diagram here, it's everything's highlighted yellow. um, the union of A and B, A union B, is the set of X such that X is an element of A or X is an element of B. So we're not using the word and, but we're using the word or. There's a big difference, right? Um, like you could say, hey, meet me after school. Okay, I'll either be in room 203 or I'll be on the football field, right? It can't be both. You can't be in room 203 and on the football field, right? They're like, it's like I'm here. It's like separate. So I'm including everything in both, right? Set A or set B is all of it. Maybe another way to think about union. I've used this example for many years now. My wife and I just celebrated our 21st wedding anniversary this summer. So we're finally 21 years old together. Actually, we've been dating longer than that, but still, we got married 99. It's been 21 years we've been married. And you've heard this word probably for a marriage. It's a union, right? If you've been to a wedding ceremony, a lot of times the preacher or the pastor, uh, we'll use the word union. Here we're joining these two couples together in a happy, or two people together in one happy union, So it's everything from set A and everything in set B all put together in one. So like, for example, before I was married, I had a house, J-Town, Willowwood Way, in the 99. You know what I'm saying? Where's my 40299s at? Let me hear you. Woo woo. 99. And it was a pretty simple house. It was me and a dog. And we had food and stuff. We had some towels and you know, we had a bed. It was nice. But I noticed after we got married, all of a sudden I had this little ceramic dolphin on my toilet. Just sat there on the back of the toilet. I'm like, where did this ceramic dolphin come from? It was like jumping out of the water kind of thing, like it was coming right out of the toilet bowl. And that's what happens when you get married. All of her stuff becomes your stuff, and unfortunately for her, all of your crap becomes her stuff, which is why you start losing stuff because she doesn't want that anymore. Um, so here, if you think about these two sets of numbers, sorry, I'm taking too long. You guys are looking at the video going, man, Mr. Quirk, you could have been done by now. Notice the set 7, 8, 9, 10, 11, and 6, 8, 10, 12. What did they both have? Not what they have in common, right? It's not what they both have in common, but what do they both have? They have everything there together. So to write out the intersection, you would just write out all the numbers that there are, and you only have to write them out one time. So whoops, I'm gonna start in numerical order. There's a 6, 6, comma, 7, 7, comma. Hey, look, there's an 8 and there's another 8, but you only have to write it once, okay? Because they both have the 8. So you don't have to write it twice. There's a 9, 9. Hey, 10, 10, 10. And then 11 and 12. Right? So that's the union of these two sets is everything in set A or everything in set B. That becomes the element of the union. Okay? Um, Pretty cool, huh? Tons of fun stuff. We've made a Google form with some questions about intersection and union, as well as some questions to review what we did earlier this week on the different subsets of numbers and which sets the numbers belong to. Okay, so I will be posting that. You can watch this video, and I will see you all in class soon. And I gotta hit stop. Stop. Bye, you guys. Peace.